This is a demonstration of the Neslab HX75 water-cooled recirculating chiller. It has a water-cooled compressor with a digital temperature readout, a temperature range of between plus 5°C to plus 35°C, and a cooling capacity of 6,820 BTU hours at 20 degrees or 2,000 watts at 20 degrees. It is equipped with a TU1 pump, which will put out 3 gallons per minute at 50 psi. It is powered by 208 to 230 volts single phase, requiring a 16.3 amp service. Let's take a look at a couple things here. First, this is the reservoir. The reservoir is approximately 5 gallons. This is where you would fill the reservoir here. I have a nice little cover there. But also, let me show you something that is important as well before we start the system. Now, this is normally used for filling, but I just want you to see this inside here. If you look from this angle here, you'll see a float. Now, if this float is not filled all the way up, it will not allow this system to run. And another thing I discovered while testing this is it's on wheels and you can move it around. But if you do, and that float goes up and down, it will shut down the machine. So it's just a little something you should keep your eyes on. Oh, I'm sorry. Also, one other thing. Inside here is a strainer. This strainer can be cleaned out on a regular basis and put back in. And it just clips right over the intake right here. Close the lid. And let's take you around the back and show you some of the connections. Again, this is a water-cooled piece of equipment. This is where your house water or your chiller water, your cooling water would come in, and this would be the drain. The drain should go directly to a floor drain. Also, when you drain the reservoir itself, this would be your drain line. When we ship the piece of equipment, it is drained of all water and we put a plug in here. But I suggest you find yourself a nice little valve if you're going to change it periodically. On the other side here, we have the actual supply and return lines. This would be going to your workpiece, your machine or whatever, and this would be the return line. This is also a very convenient flow control, so that you can vary the amount of pressure being put out. Now, when I test these units, what I like to do is go by the published specification. And what we have here, and there are several things that I like to check. We check the heating. Now, the specifications call for a maximum of 35 degrees and cooling a minimum of 5 degrees. In the cooling capacity range, we have 2.7 gallons per minute at 50. We'll see how this pump does. I just personally rebuilt this pump and it actually puts out more than that. And the cooling capacity, as per specification, is 2,000 watts at 20 degrees. So now we'll start the system. Turn power on, hit the start button. very easy to set the temperature. You can simply push and go down or go up. And right now what we're going to do is we'll test the first temperature, the highest temperature of 35. Now keep in mind that this does not have an onboard heater, but what it does use is when the refrigeration system is idle, the refrigeration gases get very hot and they go through a coil and help to heat the reservoir water. So what we're going to do is run this up to 35 and we'll come back in a little bit and see how it does. We're now up to 35 degrees, which is our specification, plus 35 degrees C as per the manual. Now what we'll do is we'll go down to their specified lowest temperature, which is 5 degrees. As you can see, this is cycling on and off very nicely to keep the temperature stable. Now we'll lower it down to its set of 5 degrees. There. But before we go away, there's two important things I'd like to show you. First, down here, I've removed the side cover, and there's a high pressure cutoff reset. What that does is, in the event you lose cooling water and the pressure rises, it will shut down the refrigeration compressor so nothing happens to it. The actual cutoff switch, if you take a look here, is right here. You have to push it hard, but as long as you push this hard, both the water system and the refrigeration compressor will come back on. Also, the second point is, when this is running correctly and loading down and cooling very hard, step this way, your drain water should look like this. This will turn on and off when the refrigeration system comes on and off. But when it's really cooling all the way down, you should expect to see a very steady stream of drain water. So now we'll come back in a little while and see how our temperature is doing. As you can see, we're already going down. So this shouldn't take too long. We're back now, and as you can see, we've gotten, the set point was 5 and we're down to 5. So it has reached its low cooling mark of 5 degrees C. So both the heating and the cooling are good. Now we're going to move on to the pump capacity, which is basically pressure versus flow. The specifications at 50 psi call for approximately 2.7 gallons per minute. So what we're going to do here is we're going to throttle this down until we reach 50 psi. Now, on the side is the pressure gauge. I could use this valve, but I'm going to use this one over here, so you just keep watching. And that should go up to 50. Got to do it a little slowly. Oop. Hold on. Oop. Sorry. Trying to get it right on 50 foot, folks. Here. Yeah, we'll leave it right there for now. There we go. And now if we look at our flow meter down here, we have, that's the center line right there, we have exactly 3 gallons per minute at 50 psi, which is actually better than spec. So we have 3 gallons per minute at 50 PSI. So that's actually a little bit better than spec. Now the last test is cooling capacity, or the capacity of this unit to be able to hold a certain temperature when under a load. So what we're going to do here, hold on, is, as we see here, at 20 degrees C, with this particular unit being a 60 Hertz HX75, we should be able to hold 2,000 watts constantly. Should be able to hold that at 20 degrees. So first, I'm going to send this up to 20 degrees. There. And now, when we look at our watt meter over here, this is very, very handy. We're going to keep going, and we're going to get up to whoop. Yeah, there we go. 2008 watts. All right. We're going to let this run for a little bit. It'll come back up to 20 degrees. And hopefully it will continue to hold that temperature. So we'll give it a little time to heat up, and we'll come back in a little bit and see how it does. About 2 hours at running at 2,000 watts at 20 degrees C. As you can see, it's been able to hold that. So we are okay with 2,000 watts at 20 degrees C. And that is our last test here. The unit is working correctly and to specification. And this completes this demonstration.